Hey, in this episode, we're going to be checking out HashiCorp's Vault. Vault is a pretty cool tool that allows you to securely store infrastructure secrets, things like passwords, certificates, API keys, and tokens. Vault is a service that sits on your network and answers queries for your secret data. When you're chatting with Vault, all the data is encrypted in transit and at rest. You can access it via a web-based UI, a command line tool, and also through a very complete HTTP API. So why would you use something like this? Well, we're all storing secret data like passwords, tokens, database connection strings, and we might be hard coding them in scripts, using environment variables, or using existing tools like the Kubernetes secret engine. I know I have tons of secrets kicking around. So I wanted to chat about Vault as it has a pretty cool feature set that goes way beyond just storing and retrieving secrets. These are the added features that I wanted to focus on today by way of a few demos. Let's quickly walk through what we're going to chat about today. This will be a pretty demo-heavy episode, as I think it's easier just to show you how it works versus chatting about it too much. So the first thing we're going to do is download Vault. Next, we're going to jump into the first demo of the day. This is where we'll cover the basics of storing and retrieving secrets. Next, in the second demo, we'll look at how Vault can act as an encryption as a service engine. Basically, you can use Vault to encrypt and decrypt sensitive or PII data on the fly. This is a pretty cool use case that goes well beyond what a typical password safe might do. Then, in the final demo, we'll look at how Vault can generate access credentials dynamically. This is probably one of the coolest features of Vault. In this demo, we'll be connecting to AWS, but this also works with other providers too, things like Azure, Google Cloud, and lots of database solutions. I also wanted to quickly mention that Vault is pretty mature and it works with tons of tools. There's a massive collection of libraries that your developers can work with when working with Vault. I also wanted to mention there's a bunch of online training labs that you can walk through. This can quickly teach you the basics all the way through the advanced stuff too. Just to add some overall context here, I think of Vault as a service that you'd run on your network that handles your secret data. So it works with containers, virtual machines, bare metal, or pretty much anything that can talk over the network to it. So that's Vault in a nutshell. But let's jump over to the download page and actually download this. I'm using a Mac today, so I'm going to download the Vault binary here, and then let's just jump over to the command line. All right, so I have the binary downloaded. I'm just going to unzip it. This is a static binary. The cool thing about this is that Vault is a network service. This single binary can act as both the server and the client. So what we're going to do is fire up Vault in a development mode, and then connect to it and run through our demos. First, let's run Vault without any command line options to get the help output. You can see the common commands for interacting with Vault, things like reading secrets, writing secrets, listing secrets, etc. Then down here we have a bunch of commands for setting things up and configuring how Vault works. As I mentioned before, Vault is a service that sits on your network, so let's fire it up in development mode by running vault server dev. This launches Vault in a development mode that's totally not meant for production, but it's really great for learning the basics. Let's scroll up here and look at the console messages. So you can see a bunch of information about how Vault is listening on the localhost address on port 8200. You also get the version information along with some other server metadata. If you scroll down a little, you can see the dev mode messages in yellow here. This line here tells us that we should export this Vault address as an environment variable, so that when we're using the Vault command line tool, it knows what server to connect to. Next, you can see the unseal key and the root token here. The unseal key is used to lock or unlock the Vault database. I think of this very much like how you'd lock or unlock, or in the Vault terminology, seal or unseal, the secrets database. Then you have this root token here. You can think of this like the access token for the root user. Vault allows you to create all types of users and policies. Say, for example, that you wanted to create a development user that only had access to a specific set of secrets. You could easily do that. But this root token is used as sort of a master key for anything that's stored in Vault, just like the root user on a Unix machine. By the way, in development mode here, Vault is storing all of the secrets in memory. Typically what you'd do in production mode is you'd store this in console or in a blob storage somewhere that's highly available. And Vault has a bunch of storage plugin engines that you can use too. Alright, so let's get started. I'm just going to open a second terminal in the bottom here. Next, let's copy this export line for the Vault server environment variable. Next, I'm also going to copy and set the environment variable for this root development token. These will be used when we launch the Vault command line tool. Basically, the client will check the environment variables and know what server to connect to, along with what user to connect as. This will just save us lots of typing as we work through the demos. Great, so now let's run Vault status. And you can see we're able to connect to the Vault server successfully. Let me just resize this a little bit. Cool, so you can see the Vault is unsealed or unlocked, and we're running our development server in a non-high availability mode. Let me just hit enter in the top panel here to make sure we're tailing the log file that's coming out of the Vault server. This can be useful for debugging things as we're working through it. We're almost ready to go, but there's one more thing I wanted to configure first. Vault allows you to log all access to the server. This is super useful for seeing who's connecting, what secrets they're accessing, and just generally having a sense of what's going on. You can check if audit logging is enabled by running vault audit list, so it's turned off right now. So let's enable it by running vault audit enable file, then the file path, and in this case I'm just going to log it to the current directory in a file called audit log. Then if we list the directory, you can see we have our newly created audit log file. We can quickly check it by just dumping the contents. Great, so as we're working through the demos, everything will be logged. This is mostly just to prove that you can do auditing, but in a production setting, this is extremely useful for seeing who is accessing what secrets and just generally what they're doing. All right, so let's jump into the first demo. We're going to be covering the basics of working with secrets by doing things like writing them, retrieving them, listing them, etc. All these links are in the episode notes below too, so you can refer back to them later. So let's jump back to the command line and store our first secret. To do that, we run vault kv put secret/hello foo equals world. Let me just explain what this does. Again, we're logged in as the root user here since we have our environment variables configured. So you can think of Vault sort of like a key value store. We stored a key called foo with a value of world in a path of secret/hello. You can list the secrets too by running vault kv list secret, and you can see our hello secret here. We can get the secret too by running vault kv get and then the path of the secret, in this case secret hello. You can see all the metadata along with the key value pair down here. Again, we're logged in as root on the development server. If this were production, you'd likely need to log in, and you'd typically have some sort of policy governing what secrets each user has access to. You can update a secret too with multiple key value pairs. Say for example, you wanted a username and password to be stored as one secret. Let's run vault kv put, then the path of our secret, so secret/hello, and then we define our multiple key value pairs. Easy enough, right? Then let's retrieve the secret again by running vault kv get secret/hello. Then you can see our key value pairs down here. So that's pretty simple, but this can be used for storing things like usernames, passwords, API keys, tokens, certificates, database connection strings, and all types of data like that. We're just using the command line tool here, but you can easily automate this using scripts or the API calls directly into Vault. You can also delete secrets. Let's list the existing secrets by running vault kv list secret. You can see we have our hello secret here. Then to delete it, let's run vault kv delete and the path secret/hello. So that's pretty much the lifecycle of secrets in Vault. You can quickly add, update, list, and delete things. Oh yeah, don't forget all this is logged in the audit log too. If we count the lines in the log file, you can see we have 29 entries. Then if we dump it, you can see we have a ton of data in here, and I'm sure you could use this to reconstruct what we did. So this covers the first really common use case of Vault, just storing simple secrets. The next use case that I wanted to cover is this encryption as a service engine. This is where you can provide data to Vault and it will generate encryption keys for you so that you can encrypt and decrypt data on the fly that you pass over to it. By the way, these secret engines are sort of modules or plugins that you can load into Vault. So we already covered the key value secrets engine just a minute ago. Now this is the transit engine. So let's jump over to the console and have a look. So we can turn on this plugin or engine by running vault secrets enable transit. Great, now you can see we just enabled the transit secret engine at the path transit/. Before we encrypt or decrypt data, we need to first create some custom encryption keys. And we do that by running vault write-f and then the path transit/keys/ and then our key. Let's just call it my key for now. So you could probably create lots of different keys here at different paths for the different types of data that you wanted to encrypt. So now that we have that set up, let's try and encrypt something by running vault write transit/encrypt/my-key. So we're saying, let's write some data into this transit engine. We want to encrypt it and we want to use my key to do it. Then let's provide a message to encrypt by adding plain text equals my secret data. But since this transit engine can encrypt not only plain text but also binary data, they want you to convert this data into a base 64 text string first. So let's wrap our secret data string here to convert it into base 64 format, and then we'll pass this into this plain text variable over here. Great, so now we get back this ciphertext with this encrypted string with our encrypted data in there. So what's the use case for this? Well, say you were dealing with lots of private data or PII data, things like credit cards, birth dates, account numbers, etc. You can call this Vault Transit Engine inside your application, and it'll do all the encryption and decryption for you. Then you just store these resulting encrypted strings in your database, and it's pretty safe. But why would you do this, though? Well, oftentimes encryption can be hard, and Vault goes through an external security audit just to make sure they have a correct implementation. So this seems like a pretty safe option versus rolling your own solution, say for compliance reasons or something like that. All right, so what about decrypting data? Well, let's run vault write transit /decrypt /mykey. So we're saying, hey, we want to use a transit engine, we want to decrypt some data, and we want to use mykey. Next, let's copy and paste this ciphertext equals our encrypted string here. Now we get back this plain text value, but it's base 64 encoded. The reason this is base 64 is that we can encrypt lots of different data, say plain text, images, PDFs, random files, etc. So base 64 is used as sort of an easy conversion format, so you can do whatever you want with it. So let's base 64 decode the string by running base 64 decode and then passing in our decrypted string. Cool, so we have our decrypted data here. In reality, you'd likely wrap this in a script or code it into your program, so it's totally automated. But it sort of shows the power at the command line for doing this type of stuff. You now have access to enterprise-grade, vetted, encryption and decryption as a service, so it's pretty cool. For the final demo, I wanted to show you the AWS engine for generating access credentials dynamically. This is a pretty cool feature of Vault, and it goes way beyond what a typical password safe might offer. Even though we're focusing on AWS here, this type of thing works with Azure, Google Cloud, Postgres, MySQL, and lots of other pluggable engines here. So let's jump to the command line and see how this actually works. Let's turn on the AWS engine or plugin by running vault secret enable path equals AWS. So each of these engines or plugins is purpose-built and has deep integrations baked in. What I mean is that this AWS engine can talk to AWS behind the scenes via APIs and actually manage user accounts on AWS for you. Let me just make this full screen since I'm going to be pasting a lot of longer commands here. So this command here is writing some config data into the AWS engine that we just enabled in Vault. Here I'm passing in my AWS management, access, and secret keys. This will allow Vault to manage the dynamic credentials on AWS for me. These AWS variables are being pulled in from my environment variables that I set behind the scenes on my laptop. So I'm just going to run this, and this will allow Vault to connect directly to AWS for me. Next, let's create an AWS role for a specific user type. Say, for example, that I wanted to give developers at my company access to run anything on EC2. Well, we can create a policy that will allow that. Let me just paste this in here and we'll walk through it. So I'm using Vault to write data into the AWS engine and create a custom role called dev. This policy here is specific to AWS, and it allows any actions on the EC2 virtual machine infrastructure. This is just a demo, but you probably want to review the docs and sketch things out how they might work for your team at your company, as I'm sure there's lots of unique roles that come up and you can sort of define policies based around that. All right, so now let's get into the cool part of creating these dynamic credentials. So let's say you have a whole bunch of developers or maybe a bunch of automated scripts, and they each need credentials for accessing things on AWS EC2. To get new unique credentials, we just run vault read AWS cred dev. This is calling the AWS engine and dynamically creating new credentials for that developer policy. You can see here we get a brand new access key and secret key. These are totally real credentials that Vault generated by chatting with AWS behind the scenes. Let me just pull up the AWS console and show you the users tab here. So you can see we have our newly created user account called vault root dev ... that was created today. So let's jump back to the console and run that vault command again to generate a second account. This time we get totally new unique credentials again, and you can see the keys are different than before. Just for fun, let's create a third account. All right, so why would you do this? Well, without Vault, you often create a single shared account and you pass it around. But the problem with that is that you quickly lose track of where you used it. Or what if something gets broken into, or maybe a developer leaves your company? Are you really sure they don't still have access to your environment? So if you use something like this dynamic option here, it becomes extremely simple to generate expiring keys on the fly. You can use this to do things like generate a unique key for each web server in your fleet, or maybe a unique key for each automated script that runs nightly. Then if something gets exposed, you can quickly limit the damage or audit what happened on that particular instance, along with when it happened. All right, so let's jump back to the AWS console and reload things here. We should see our 3 dynamically created accounts. Pretty cool, right? This not only works for AWS, but Azure, Google Cloud, Postgres, MySQL, etc. There's tons of engines for pretty much anything where you need authentication. So let's jump back to the command line and create a fourth account here. So along with this dynamically created account, you can see this lease duration value of 768 hours, or about a month. What this means is that the account will automatically expire in a month and the credentials will be removed by Vault. You can change this though. Let's run vault write AWS config lease equals 30 minutes, and lease max equals 30 minutes. So we're writing some configuration data into the Vault AWS engine, setting the dynamic account credentials to expire in 30 minutes. By the way, this isn't retroactive, so it only affects things we create from now on. So let's create a fifth account by running that command again. Great, so now you can see our account expiry time used to be a month, but now it's 30 minutes. You can set this by role accounts too, so each type of account has a different lease time, maybe for developers versus short-lived automated scripts or something. The cool thing about this is that having an account that expires in, say, 30 minutes for a quick automated task is pretty cool, in that if something bad happens and the credentials are leaked, then it's pretty time-bound window where something bad could happen versus having a shared credential that sticks around for months or years. So let's jump back to the AWS console and refresh the account list here. We should now have our 5 accounts. Great, so it worked. Personally, this is probably the coolest feature of Vault for me, as it allows you to quickly generate time-bound credentials on the fly. I'm not going to cover it today, but there's also a pretty cool Vault SSH engine for handling dynamic authentication credentials for logging into boxes too. This can be really useful for locking down access after someone leaves. Alright, so let's jump back to the command line. There's a problem though. I've actually created real AWS dynamic credentials and I'm showing you the real keys here on the screen. So you could easily copy and paste these and run things in my account. Well, say for example that you actually did this, like me, and maybe you posted them up to GitHub. You can easily revoke all the keys Vault created. Let's run vault lease revoke prefix AWS/. This revokes all the AWS dynamic keys. You can also do this on a one-by-one basis, but say for example that you quickly needed to lock down complete access, you can do it this way. Let's jump back to the AWS console and reload things to see if this was actually deleted. Great, so we have no AWS dynamic accounts left. Pretty cool, right? I really like how we can create these time-bound, unique authentication codes per app or person here that will auto-expire. This is really useful for limiting the exposure of your authentication tokens, say for example when people leave, or for tracing where a leak happened. So you might remember back in the beginning how we enabled that audit log. If we count the lines in that file, we're now at about 79 entries. Let's just dump the contents to the screen here. So I'm sure you could dig through all these logs and reconstruct what happened. Alright, so that's my quick and dirty tour of Vault. For a long time, I've hard-coded things or maybe used environment variables or had an external file where I'd pull in the secrets on the fly and do things. But with Vault, you can do all this cool stuff in a nice little package. It has a bunch of cool plugins or engines that work with all the cloud providers, configuration management solutions like Ansible, and I'd highly recommend checking it out if you're running a medium to large infrastructure stuff. Alright, that's it for this episode. Hopefully you found it useful. I'll see you next week. Bye.